Hello class, welcome back again to my Applied Science College channel. Today we are going to discuss on the chemistry titration practicals. We are going to embark on them and also to discuss qualitative analysis part of that. So this, in other words, I'm just trying to say that this is a full paper, practical paper. So we are just going to start with the questions straight and then the questions, and then we see how these questions are supposed to be answered. So I will be asking questions, and at the same time I explain how are those questions are supposed to be answered. So straight away we start the procedure. You are provided with the dilute hydrochloric acid solution A, and then we also have solution B. Solution B, 0.5 molar sodium hydroxide. You are required molarity of sodium hydroxide solution B. Procedure. Fill the burette with the solution A. Pipette 25 cubic centimeters of solution B into a conical flask. Add 2 drops of phenolphthalein indicator and titrate with the solution A. Repeat the titration 2 more times and complete the table that is below. If you just complete the table, then you will be able to get 4 marks. So this titration, this practical, it was done, and the titer volume was in the first column. They got the end point came at 20.0 cubic centimeters, and then on the second column, the second titration after it has been done, they refilled the burette after they have titrated from 20, and then they refilled to 0 mark, and then they titrated, and then they also got 20.0 cubic centimeters. The same applies to the third column. So for the complete table, we were very accurate with our results, and we got, for the complete table, you are given 1 mark, decimal point 1 mark, and then also the average 1 mark, and the PA and FA 1 mark, 1 mark. So for full complete table, you will be given 5 marks, 4 marks, and then if you calculate the average volume of the solution A used, you also get another 1 mark. So we were told to calculate the average volume of solution A used. We took 20 plus 20 plus 20 divided by 3. We got 20.0 cubic centimeters, which was the average volume. And then we were told to write the equation, for the reaction that took place. So that is 1 mark. So sodium hydroxide, when it reacted with the hydrochloric acid on the reactant side, the products were as follows. They were sodium chloride and water. Water, which is a liquid, sodium chloride, which is an aqueous, and hydrochloric acid, which is an aqueous, and finally sodium hydroxide, which was also an aqueous. So on you can be able to see the reactants. We were having sodium hydroxide and hydrochloric acid. Those ones were reactants. So, and then the products, after reacting, we got sodium chloride and water. And then we went an extent of answering. We were told to calculate the number of moles of sodium hydroxide solution B in 25 cubic centimeters used, and they were 2 marks. Remember that the pipette that we were using, it was labeled, it's supposed just to carry a specific volume of a solution, which was 25 cubic centimeters. So we were supposed just to take, we need to ask ourselves, if 1,000 cubic centimeters has 0.5 moles, what about for 25? And then we cross multiplied, and then we got the final answer to be 0.0125 moles. So procedure 1 mark, and then the answer you got in the number of moles that you got, also it is also another 1 mark. So those ones were 2 marks. So that is what we did, and then we went to an extent of answering question C, Roman 2, the number of moles of hydrochloric acid in the average solution used. So since the mole ratio was 1:1, because of that equation, the mole ratio, as you can see, it is 1:1. The number of moles that were on the the number of moles of sodium hydroxide, they were the same as the number of moles of hydrochloric acid, which was 0.0125 moles. And then we were told to calculate the concentration of solution A in moles per liter, which was 2 max there. So we went ahead and asked ourselves, we just took 0.125 moles, and then we multiplied by 1,000 over the average volume, which was 20. Then we got, if you do your mathematics properly, you'll be able to get 0.625 moles per liter. That is the molarity of that solution A. And solution A, remember, it was hydrochloric acid. And then we went to an extent, we were supposed also to answer Roman 4 of that C. We were told to calculate the concentration of solution A in grams per liter, and then we were given the relative atomic mass of chlorine, 35.5, and then hydrogen, which was 1. And then we went to an extent of getting the relative formula mass of hydrochloric acid, which was 35.5 plus 1, which was 36, which was giving the final total relative formula mass of hydrochloric acid to be 36.5, because we took 35.5 hydrogen and then chlorine plus hydrogen, which was giving us the total of 36.5. Then we went to an extent of getting the concentration. Concentration is equals to the relative formula mass times the molarity. Those ones are the number of moles per liter, which was giving us 22.8 grams per liter, as indicated there. Question 2, you are provided with solid D, and then we were told to add 15 cubic centimeters of distilled water and shake well until all of it dissolves. Use 2 to 3 portions of the solutions to carry out the tests below. And then we went ahead and answered those questions. To the first portions, we added sodium hydroxide dropwise until in excess. So observations that was made, we find the white precipitate soluble in excess, and then we concluded that that solution was containing zinc ions, lead ions, or aluminium present. So we went ahead of the same solution. After dividing the second portion, we added an aqueous ammonia dropwise until in excess. So we also find the white precipitate, which was soluble in excess. So we also concluded that zinc ion are present. So we went ahead to the third portions, and then we added 3 drops of barium nitrate solution. Keep the mixture and then the procedure is saying to keep the mixture for test D, 3 max. Then we found white precipitate, and then we concluded sulfate ions are present. Also, sulfite ions are also present, and then carbonate ions are also present. And then D, to the mixture above, we added equal volume of dilute nitric acid, which was 2 max. Dilute nitric acid, which was 2 max. So observations was white precipitate does not dissolve, persists in with the effervescence, which means sulfate ions are present. Then you are provided with organic solid E also to carry out the tests below using solid. Scoop a half of the solid in a clean spatula and burn it. So we burnt, and then we found that it was burning with a yellow, sooty stroke smoky flame. So we found that either it's an alkene present or an alkyl present, because of the double bonds or the triple bonds were present. So place the other half of the test tube and 5 cubic centimeters of distilled water and shake until all of it dissolves. Add 2 drops of acidified potassium permanganate. When you do that, you will get that acidified potassium permanganate it decolorizes. So which means that it is what? An alkyl present, an alkene present, or alkyl compounds present. So for those short remarks, remember to share, to subscribe, and also to just give some comments down the video. So meet you next time when I'll be coming up with another visual practical class. Otherwise, thank you in advance, and we shall be meeting soon. Bye bye.